Now that we have talked about equations and we know how to solve them, and we've talked about fractions and we know how to do all the operations with them, we get to start putting them together. So we are going to start by solving some equations, and we're going to do so that have fractions in them. And we've already done this a little bit, but now they're going to be a little bit more complex. So we might have multiple steps to do along the way. So solve, which you remember means find the value of the variable that makes the equation true. Okay, here's our first one. 1/2 y. So I want you to pay really close attention to the notation I'm using, how I'm writing these, because I'm going to mix it up and vary it, right? Because we're talking about how we can often see the same thing represented multiple ways. So take a look at this. Oops. First problem. Scan it, pause, right? Look at it, try it, examine everything that's there. What do you notice, right? I notice there's the equal sign right here. So I got my left side, my right side. The left side has two terms. One of them has a variable, the other does not. Over here, this one does not. So the entire equation has one variable term, which can stay right where it is, and two non-variable terms. So we're going to start by removing the term that's over there with the variable, but is a constant, right? So we're going to get this 3 out of the way. We do that by adding 3. So that's no different than any other equation that we've worked with already. Then we have 1/2 y. This is now 0, right? 1/2 y plus 0 is just a half y equals -23 plus 3 is -20. All right. So this is where we start to notice something that looks familiar. We did this a while back. We have a fraction in front of the variable. We have a fraction coefficient. And if you recall, the way that we remove this fraction is by multiplying by its reciprocal, which is 2, or 2/1, right? 2/1 is the same as 2. We can write it like this, or we can write it like that. Hey, look how I did that. I multiplied both sides of the equation by 2, but I wrote the number 2 differently on both sides because it was helpful on this side to put 2/1 so I can see how everything cancels. But over here it was helpful to just write 2 because it was a whole number. So what do we end up with? Y is now isolated by itself equals -40. -20 times 2 is -40. And we could always go plug that back into the equation, -40. What's half of -40? -20. Subtract 3, you get -23. So that is a true statement. Let's try another one. So the next one is 5x over 6 is equal to 3/4. Now this kind of looks familiar, I hope. So the thing I did a little bit differently was instead of putting the variable off to the side of the equation, it's now up in the denominator. But do you remember that 5x over 6 is the same as 5/6 x? Do you remember that those really mean the same thing? The variable can be off to the side or up top. Do you remember why? Do you remember how I proved it in a previous video? So the whole idea here is we still have to cancel, right? We need to get rid of that 5/6. The coefficient is 5/6. So we multiply by its reciprocal. We multiply both sides by 6/5. And I'm going to write that as a fraction over here too, because everything's a fraction in this case, right? I didn't draw my line, right? Here's my line. Multiply by 6/5. What happens? The 6's cancel, the 5's cancel. All we have left is this x equals. Now over here, how you finish off this problem will differ from other people in the class. Some of you might start by just multiplying and multiplying to get 18/20, and then work to cancel and reduce that. Others of you might take this and immediately go through how I've been trying to teach you how to cancel stuff and reduce fractions. 3/20 2 times 2, right? 4 is 2 times 2. Times 6, which is 2 times 3, right? Thinking about prime factorizations and how they can help you cancel. And then you multiply everything back together. 3 times 3 across the top, 2 times 5 across the bottom, right? This will get you to the same spot. Sometimes it's easier to do one way or the other. I'm going to leave it up to you to figure that out, right? That's the whole idea about math. We want to be efficient. We want to take the shortest path, right? We want to get the solution in the most efficient way. If you don't, that's okay, but that's the eventual goal. Next, we've got a couple more we're going to look at. So x over 2 plus 3x over 4 is equal to 5/3. Oh dear, wow, this looks fun. So this is where they do start to get complex, complicated. Take a look at it. What are you thinking? What are some things you notice? So here's what I notice. I notice that we have 3 terms. 1, 2, 3. I notice that the 2 terms on the left both have variables. They both have an x. So even though they have fractions in them, they are considered like terms. Oh, so these two are like. Remember, to be like, they have to both have the same variable. Right? They both have an x. Over on the right hand, this is a constant, right? This is a constant. Even though it's a fraction, it's just a number. So, we can combine like terms. We can add them together. And when they're an equation on the same side, we can add them together. Agreed? However, if they're fractions, you can't add them together unless they also have the same denominator. So they don't this time, so we're going to change them so that they do. What do I see? I see that this denominator is a 4, which is the same as 2 times 2, right? That's the factorization. This one has a 2, so in order to make it the same as this one, I would need to multiply this one by 2 on bottom and a 2 on top. That will give me a 4 on the bottom. That'll give us the same denominator. So we're going to take our first step and just sort of modify the way these look over here. 2x over 4 plus 3x over 4 equals, bring this down, 5/3. So now, on that left side, to simplify it, all we're doing is combining the 2 terms together. They have the same variable, x and x. They have the same denominator, 4 and 4. So we can add them together, which means adding the numerators, 2x plus 3x is 5x, and the denominators are still 4, right? We're counting how many fourths there are. Now it looks like the previous problem. We have a fraction. We have the x on top, or you could put it off to the side. Equals a fraction. We want to multiply by the reciprocal of this one, right? Wherever that x is, multiply by its reciprocal, which would be 4/5. So times 4/5. All of these things cancel. That's always our goal. We want all this stuff to cancel out. X is all that's left. X equals, this is set up nicely. The 5s are already identical, so they cancel immediately. Remember, when you cancel something, there's always a 1 in its place. When you multiply, you're left with 4 on top and 3 on bottom. So x must equal 4/3. That's when you might want to go back and watch again. And try that again. We have one more to do. It is solve 1/10 equals 4/5 x plus 3/10. Pause it and try, right? Pause and try. I'm going to keep going. So I pause, I look, I scan the whole problem. I just take inventory of everything that's there. You never try to solve any problem in life without examining all the situation. There's the equal sign, right? I'm separating my left side and my right side. So what I notice is, first of all, my variable, I've got a variable. I only have one term with a variable. It's right here, and it's on the right side. These two terms don't have variables. They are the constant terms, and they're on opposite sides. So unlike the previous problem, I don't have like terms together on the right side, the same side. So I can't combine these. You might be tempted to say, I need to get rid of that 4/5. I don't like it. You've got to hold on to that for a minute. You can't get rid of the 4/5 until it's the only term on its side. So we need to get rid of the 3/10. We need to subtract 3/10 from both sides. That's the constant term, right? We're eliminating it from this side, so it'll be 0. And now it's over here on the left side. So 1/10 minus 3/10. You might even write it over here, right? Just to make sure you're going to work it properly. Subtract across the top. 1 minus 3 is negative 2/10. So we have negative 2/10 on the left and 4/5 x on the right. Now, some of you might be thinking, hey, can't we reduce 2/10? Can't we reduce that fraction to something simpler? Because 2 and 10 are both divisible by 2. You can. You actually can reduce it. In fact, it's a helpful thing to do in this particular problem. And so whenever you can simplify stuff, try it. Do it. I can take a 2 and cancel a 2 or remove a factor of 2 from the top and the bottom. Divide them both by 2. It'll give me negative 1/5. It's the same thing. Equals 4/5 x. So all I did was I simplified that. I changed it to that. All right, we're almost done. All we have left to do is get rid of this thing. So notice how in this problem, I didn't put the x up top. I just put it off to the side. We're still getting rid of the 4/5 by multiplying by its reciprocal. I don't even need to write it right next to it. I can put it over here. And then I need to write times 5/4 on this side. So 5/4 times, I'm going to put parentheses around this just so I don't get mixed up, right? That negative, right? It's always nice to house that in parentheses. Now be really careful. Okay, here's our equal sign. I'm going to work over here first. The x is still there, but the 4's cancel and the 5's cancel. So all that's left over here should be the x. Over here, I noticed that I've got 5's. That's why it was nice for us to reduce this. The 5's can cancel, and the only things left are the negative, the 1 on top, and the 4 on bottom. So x must be equal to negative 1/4. Now we know how to solve equations, more complicated equations that have fractions in them.